7.5 Properties of Logarithms. So we've dealt with logarithms the last couple of sections. Now we're looking at some of the properties. They're similar to the properties of exponents. With the product property, if I have log base b of m times n, then I'm going to separate. Just like if I had exponents multiplied, I can add them. I can now separate the logs and add them. So I can have log base b of m plus log base b of n. So I have to separate the m and the n and put them each in their own log. With quotient property, if I'm dividing inside that log, then I can separate each one into their own log and subtract. With power property, if I have log base b of m to the n, that n in the exponent will come out front. And now it's n times log base b of m. So let's go and put some of this to use with example 1. So in example 1, it says use log base 2 of 3 approximated at 1.585 and log base 2 of 7 is approximated at 2.807 to evaluate each logarithm. Well, we have log base 2 of 3 divided by 7. So we're going to have to separate those using the properties on the previous page before we can use these estimations. Again, just like exponents, since I'm dividing here, I'll separate them and subtract. So I have log base 2 of 3 minus log base 2 of 7. So the base will stay the same in each one, and I just separate. Now I have estimations up here. Log base 2 of 3 is 1.585, so I'm going to plug that in, 1.585, minus log base 2 of 7 is about 2.807, so I'm going to plug that in. Now, just plug in your calculator, 1.585 minus 2.807, and you get negative 1.22, whoops, 2. Okay, an extra little dot up there. Alright, so now let's look at log base 2 of 21. Well, with my estimations up here, I have a 3 and I have a 7. Think of ways that you can use 3 and 7 to make 21. The first thing that comes to my mind is multiplication. So this can be log base 2 of 3 times 7. Well, using the properties from the previous page, I now can use the product property. Since I'm multiplying inside the log, I can separate and add. So I have log base 2 of 3 plus log base 2 of 7. Now use your estimations just like before. So this is 1.585, and I'm adding 2.807. Go ahead and put that in your calculator, and when you do, you are going to get 4.392. And the last one over here, log base 2 of 49. Think of ways you can use 3 and or 7 to get 49. Again, with me, the first thing that comes to my mind is log base 2 of 7 squared, because 7 squared is 49. This is going to be the last property on the previous page, and it's dealing with that exponent. So you're going to take that exponent and drag it around to the front. So if I rewrite this, I now have 2 times log base 2 of 7. Well, I have an estimation for log base 2 of 7, so I have 2 times 2.807, and we can put that in our calculator, and we get 5.614. Okay, let's look at example 2. This says to expand The natural log, everybody's thinking this is in, it's not, it's an L. So this is going to, we're expanding the natural log of 5x to the 7th divided by y. Well, use your properties that we just went over in that last problem and then on the first page there. So natural logs and logs, they have the same properties. I'm going to rewrite this natural log of 5x to the 7th divided by y. Work with the top first. Remember, when you're multiplying, you can add. So my next step here is natural log of 5 plus natural log of x to the 7th. Now, all in the same step, I can go ahead and take care of this division right here. When you're dividing, you now subtract. So I can go ahead and say this is minus the natural log of y. There is one more thing here that you can do, and that's dealing with this exponent right here. So rewriting the beginning, I have natural log of 5 plus, now this 7 is going to just pop around in front, and I have 7 times the natural log of x, and then minus the natural log of y. And that's what they mean when they say expand. You're just expanding it out. You're not trying to put anything in the calculator and find an exact answer. Okay, now this one. This one's going the opposite direction. This says condense log of 9 plus 3 log 2 minus log 3. So remember, when there's not a base, it's base 10, but in this case right here, we don't necessarily need to write the base of 10. They all have the same base, which is an understood 10. We don't have to write it at all. So I'm going to rewrite the problem. Log of 9 plus 3 log of 2 minus log of 3. So if you remember in example 2, the last thing we did when we expanded was to take the exponent and put it out front. So when we condense, we're working backwards basically, and that's going to be the first move. So we're going to take this coefficient out front, and we're going to put it up on the exponent right there. So now I have log of 9 plus log of 2, and now that's an exponent of cubed minus log of 3. Now we can go back basically in the same order that we did but backwards on the previous problem. If you're adding your logs, then you can go through and put them in the same log and multiply. So log of 9 times 2 to the 3rd, and then when we subtract, so this right here is subtracting, that means now I'm going to divide by 3. It does say condense, so let's go ahead and condense it as much as we can. I have log of 9 times, well, figure out 2 to the 3rd. If you put that in your calculator or if you work it out, 2 to the 3rd is 8 divided by 3. Now go ahead and actually work that out. 9 times 8 is 72. So I have the log of 72, and then go ahead and divide by 3. And you will get, we don't want to write that there, we want to write it below. So now you're going to get the log of 24 as your final answer. So always make sure and simplify. I cannot stop right here. I have to go on down and simplify in here. There's no variables, it's all numbers. So go ahead and make sure you simplify all the way down to your final answer. Alright, now let's look at change of base formula. If A, B, and C are positive real numbers, with B not equal to 1 and C not equal to 1, then I can say that log base C of A is the same as log base B of A over log base B of C. So basically, this A right here went to the top of your fraction. This C that was in the base went to the bottom of the fraction. And then they now both have a new base that is the same. So looking at this again, this is in particular log base c of a. So the a from here goes up top. The c from here goes on the bottom. You can write a random base of say 7 or 9 or anything like that, or you can leave it blank, which means it understood 10. You can also change from a regular log to natural log. So right over here, log base c of a, this a is written here, this c is written on the bottom, and now I've changed from regular log to natural log. So that can be done in your change of base formula. Just pay very close attention to what you're doing. So let's use that here in example 4. Evaluate log base 3 of 8 using common logarithms. Well, common log is the log log. So if I have log base 3 of 8, I'm going to split that up and put log of 8 divided by log of 3. The 3 is lower because it's the base, so that means it's going to go on the bottom. You can put your base of 10 in there, but you don't have to. Just put it in your calculator as is. So in your calculator, you're going to type in parentheses first. Make sure you put your parentheses, log base 10 of 8, and then close your parentheses, divide, open parentheses again, log base 10 of 3, and close your parentheses. And when you do that, I'm not going to write equal to the right, I'm going to write it below. You are going to get 1.893. Now, do not put this in your calculator and get a decimal. If I do not see all of this work right here, then you will not get credit. So make sure you are paying close attention and make sure that you show all of that work. Let's use one more, do one more. This one says to evaluate using natural logs. So I have log base 6 of 24. I'm going to rewrite the problem, log base 6 of 24, and now rewrite using natural logs. ln is your natural log, so ln 24 divided by ln 6. So just put that in your calculator, ln 24 divided by ln 6, and you get 1.774. And there you go. And the last one. Here's your big word problem. This is the last problem that we're going to do. So we have, it says example 6, for a sound with intensity I in watts per square meter, the loudness L of I of the sound in decibels is given by the function L of I equals 10 log of I over I sub 0, where I sub 0 is the intensity of a barely audible sound, which is about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of a track so that the intensity of the sound doubles. By how many decibels does the loudness increase? Okay, guys, this right here, you're not looking at anything except properties. That's all you're basing this off of is properties. You are using this. So if the sound intensity doubles, if it doubles, it's now instead of L sub I, or L of I, it's going to be L of 2I. And if we need to find out how much it increases, then we're just going to simply subtract L of I. Well, instead of plugging in all these numbers and everything, then we are just going to plug in the formula. So if I have L of 2I, Then in place of every I have 2i from the given formula that was up above. So 10 log, instead of I have 2i, and it's divided by I sub 0, minus the regular formula, or regular function, 10 log of I divided by I sub 0. Now comes our function's properties, our log properties. Well, first of all, let's factor. They both have a 10 out front. So instead of complicating things, let's factor it out and put that 10 out front. So that 10 is now out front. And then I have log of 2i over I sub 0 minus log of I over I sub 0. Okay, so now look and simplify. So I have a 2 multiplied out front right here. Use your log properties. So I still have my 10 that's sitting out in the very front. Using log properties, I now can separate this and make this log of 2 plus log of, I don't want to separate those two, and I'll show you why in a second, but that's going to be log of I divided by I sub 0. And then I have my minus log of I divided by I sub 0. So the reason I did not want to separate this I and I sub 0 is because right here I have log I sub 0, minus log I divided by I sub 0. These two right here are the exact same. One's a positive, one's a negative. So they are going to cancel. Then I am left with 10 times log of 2. That right there is something that I can put in my calculator. So if I put in 10 times log 2, I'm going to get 3.010. So when it says by how many decibels does the loudness increase, you can say the loudness increases by 10 log 2 decibels, which is about 3 decibels. So the majority of all of that was simply log properties. Then once you get all of the i's out of there, you can put it in your calculator. If you have a problem like that on your assignment, then make sure you refer back to this example, and it will be very, very, very similar, because your formula will most likely be very similar as well.